Hi, welcome to Beginning Statistics. I'm going to talk about sampling in the practice of statistics. So why do we sample? Well, let's look at a couple questions. How tall are the students at NCTC? What's the average income of American families? What percentage of voters favor a particular candidate before the election? So it's not easy, it's not cost effective to ask every single person one of these questions. So instead, we select a group, a smaller group. We use the answer from the smaller group to kind of tell us about the whole population. In statistics, what we say is we take a sample from a population and we use the statistic or the descriptive statistics from that sample to make inferences or to estimate a population parameter or the numbers, the summary of the population. So there's two letters that we need to start with, okay? The first letter being the uppercase N. Uppercase N represents the size of the population or the number of the observations in the population as a whole. The lowercase n represents the size of the sample. Key to understand, though, when you see n equals 100,000, if it's an uppercase n, that's the population. Has 100,000 observations. One of the important things about sampling is we need a representative sample. So we need a sample from the population that includes kind of all the demographics that are also in the population. If you don't have that, then what you can get is bias. Kind of think back when we talked about in doing the experiment, if all of the women received one pill and all of the men received a different pill, then you have a bias. And so we have two different samples there. We're not including all the demographics. A similar kind of thing, if you take a sample and you take a sample of just all men and the population has men and women, then you have a bias in that sample. So you need a sample that has all of the demographics. Here's an example of kind of a sample that went bad. 1936, a poll was conducted to determine whether Franklin D. Roosevelt would be reelected. Their sample was not representative of the voting population, so there was some bias. And the poll predicted that FDR would get 43% of the votes. So if you're opposing FDR, you're thinking, well, yeah, 43 is pretty big, but, it's not too much, it's not too high. In actuality, he got 62% of the votes. That is, their population or their sample was 19-point difference. Now, one thing to note here is this is points. You think of percentage points. So the difference between 43 and 62 is 19 percentage points or a 19-point difference. We wouldn't say this is a 19% difference because percent is a percent of something. These are 19 percentage points or 19-point difference is what you would call it. So what's the best way to pick a sample that represents the population? Well, there's several ways to do that. There's what we call a simple random sample. And I'm going to just kind of high level. Here's what they're called, and then we'll get into the details. Then we have a stratified sample. We have a systematic sample. We have a cluster sample. And we have samples of convenience. These are kind of in order of power, clout, how well they represent. So the samples of convenience is the worst one. Simple random samples are probably your best one. So let's look at the first one, the simple random sample, and we'll call that SRS. It's where everybody in the population has an equal opportunity to be chosen in the sample. This is the sampling method that we'll be using in the next few chapters. This is the kind of the go-to way that we're going to try to do. Think of it as kind of you put a ticket, you shake it up in a hat, and everybody has the opportunity to pick that ticket or that number of that ticket. The reason it works so well is what we call the law of averages. And the law of averages allows us that if you continue to sample from the population, then the averages that you're going to get in your sample are going to represent or are going to be very close to the averages of the population. So if the population has 52% men, and if you take a sample from that population and you look at the percentage of men, you'll get something close to 50%. Now, if you take another sample, a different, put that sample back, first one back, take another sample, a second sample, and what's the percentage? And it's going to be close to 52%. You do the same thing and you repeat it and you repeat it and you repeat it. As you get to like 10, 20, 30, 40, 100 different samples, and you look at those percentages, they're going to just get closer and closer to the percentage of the population. That's called the law of averages. That works very well for us in simple random sampling. Like I said, it's just you're using chance to select individuals from a population. Chance is kind of the same thing as saying you put a bunch of numbers in a hat, shake them up. Well, it's chance. So we need some sort of random chance to do that. Technically, random sample is when a sample size of n from a population of uppercase N is obtained through a simple random sampling where every possible sample of size n has an equal likely chance of occurring. There's some steps that we want to take to ensure that everybody has that equal opportunity. First thing is we start out with a frame that lists all of the individuals in the population of interest. And then we number those individuals from 1 to the total number. So if you have 300 individuals in a population, then we need to list every one of those individuals from the first one with number 1 to the nth one or the 300th one. So we want to number those from 1 to 300, each one of those. And then we use a random number table, a calculator, or some sort of software or some way to randomly generate n numbers or the sample size. So of that 300, maybe we're looking for 30. So we need to generate 30 random numbers between 1 and 300. So we're going to randomly, so then we pick, those are the numbers that we're going to use as the sample. Now, it's just a note, if you use a random number generator, they need a seed. You got to start it with some sort of number. The best way to do that is start it with some sort of non-zero number time. If you look at your watch and say what time it is, that's going to be kind of a random number. Simple random samples are very effective because they don't cost very much to do. And it's better if you can't reach the whole population. Then you can randomly select a portion of that population. So generally, random samples preferred over non-random sample. And the larger the sample size is going to be more accurate than the smaller the sample size. Kind of makes sense. And this helps support this law of averages. But typically you'll see the sample relative to the population, the sample is going to be relatively small to the population because larger samples cost a little bit more to do than smaller samples. If you have a population of 3 million, if you want to do a large sample of 300,000 out of that 3 million, well, that's kind of a big sample size versus if you did a sample of 3,000 or even 300. So it kind of works against itself if you go for larger samples, even though you have a better representation, there's a cost implication as well. Here's an example of doing a random sample. Okay. And get a simple random sample of 10,000 citizens of voting age. A polling organization randomly draws Social Security numbers from the database, ignoring the ones assigned to minors, right? So, because we want voting age, so we're going to ignore minors until they have 10,000 people in the sample. So we don't know what the population is, but it's a voting age let's say database, social security numbers of a large population, we'll just say. So they're going to randomly select, everybody has this number, right? Social security numbers. And so they're going to randomly select 10,000 people from the sample to get based on their social security number. So they'll just randomly select social security number out there. Now, if that social security number represents a minor, then they'll just throw that away and go for another one. Here's a different example. The House of Representatives has 435 representatives. How would we obtain a simple random sample of 5 members out of 435? These 5 members are going to attend a presidential luncheon. So the way we do this is we put the numbers in in alphabetical order. So the 435 members in alphabetical order. We number them 1 to 435, and then we randomly select 5 numbers between 1 and 435. We use some sort of random number generator to do that. Then we match those numbers that we randomly selected, to a corresponding representative. Now, the random number generators, we'll get into detail a little bit more later, but sometimes that's using just a table of numbers that are randomly created and kind of dropping a pin and saying, what number does it hit? And then just start with that number and go down. And what's the next number? Now, if that number is a single digit number and you need like 435, you would need 3-digit number. So we would say if our pin landed on a number that was 3, then we go, what's the next 2 numbers next to it? Maybe that's 326. So that would be our first random number out of the 435, 326. Then we would go below to the next number below that, which would be a random number because these tables are created randomly. But we use the pin where we drop as a starting point, and we pick 3-digit and call it 326, and then what's the next number down below that, the next 3-digit number, and next number, and until we get 5. And then we would have 5 random numbers. Okay? That's all, folks.